Okay, so we're going to do a few on this page. This is our average velocity page. Some of them I'm going to write down, and some of them I'm just going to say, and you're welcome to write that down. So, average velocity. Let's do number one. When is an object's average velocity different from its average speed? So if we remember our example from earlier, our speed would just be how fast, and our velocity is like how fast with the direction. So when an object's, let's say its average velocity is 20 miles an hour north, and its average speed, we'll say it's 20 miles an hour. When they differ is when there's a direction change. So maybe the velocity, the average velocity starts, maybe the car starts turning to the left, but it's maintaining 20 miles an hour. Well, at that point, the velocity, average velocity is changing because the direction's changing, but the average speed is still 20 miles an hour. So the answer we're looking for this one is when it changes directions, okay? All right, let's go to number two. When is an object's velocity different from its average velocity? By the way, if you want to take some time to try to figure these out, pause it, see if you can figure out, then unpause it, and then that'll give you an opportunity to see if you're right rather than just sort of hearing the explanation. So, velocity is just more or less your speed with the direction. Average velocity is your overall speed over a given time. So remember, it's your change in displacement over your change in time, right? So that being said, if it had a velocity of 20 miles an hour north, and its average velocity, we'll say, was 20 miles an hour north, when those two things are different is when there's some kind of accelerating, whether that's positive acceleration or negative acceleration. Because remember, let's say they go 1 mile, right? And they're going 1 mile north, and one car stays at 20 kilometers per hour the whole time for an hour. Whereas this other car has an average of 20 miles an hour, 20 kilometers per hour. So that means at some point maybe it's going 25 kilometers per hour. At some point maybe it's going 15, but the average is 20 kilometers per hour. So in that case, the answer that they're looking for is when it accelerates. And keep in mind, you can have positive acceleration and you can have negative acceleration. Positive acceleration means speeding up, what we're probably used to. Negative acceleration just means slowing down, right? So let's look at number three. What does it mean to go 30 miles per hour? So, a couple of answers for this. You could say that every hour you're traveling 30 miles. You could also say, and I think this is a better answer, that on average you're moving 30 miles each hour. So that means you could be moving a little bit faster at some points during that hour, or a little bit slower, but on average you're traveling 30 miles each hour. Okay. All right, let's move on. Let's do number four. Let's cover some of these up. It's not distracting. All right, so a car travels 480 miles west in 8 hours. What is the average velocity? So, first we got to do is write down what we know. So we know, let's write it off under B just because we have more room. We know that the distance is 480 miles. We know that the time is 8 hours. So now what we need to do is figure out what it's asking. I'm going to go ahead and highlight that too, just because it saves a little bit of time on the eyes when you're trying to re-find it later in the question. So first thing we need to find is average velocity. So we know that average velocity is the final distance minus the initial distance divided by the final time minus the initial time. All right? So the initial time is 0. The final time is 8 hours. So let's write our formula real quick. We know that average velocity equals distance. Change in distance over time. Okay? We know that our distance, our change in distance, remember, if they started at 0 and they ended at 480, it's final minus initial, so the final is 480 minus 0. So let's rewrite this. Equals 480. 480 over, what's our time? Well, our final time was 8 hours, and our initial time was 0, so it's going to be over 8. So our average velocity should equal 60 miles per hour. Okay, so this is the answer to A. Okay, even though we're writing it under B, it's just because we had more room. Now, next question. Do we know the car's velocity? Let's highlight that because there's a lot of stuff going on here. Do we know the car's velocity after 2 hours? Okay. How about after 4 hours? Why not? Okay, so remember, this is very similar to this number 2 that we did. It's very similar to number 2 because, remember, average velocity just means about how fast it was going during this time. About how fast. Doesn't mean we know it was going X speed the entire time. We just knows about how fast. The average in those 8-hour span was about 60 miles an hour. Okay? So when it's specifically saying, do we know the car's velocity in 2 hours? Well, no, we don't. Which means we still don't know it in 4 hours, right? Because, like we said, it's an average. So it could be going, heck, it could be going 100 miles an hour in 2 hours. Just as long as it goes much slower than 60 some of those other hours, so it averages to be 60 miles an hour, right? Same case for 4 hours. It could be going 2 miles an hour at the 4-hour mark, but maybe at the 5-hour mark, it was going, 120 for a little bit. Just as long as the average is 60. Okay? So with that being said, the answer to B is we don't know. No, we don't know 2 hours. No, we don't know 4 hours. Because we need more information. Okay? We can only calculate the average. Awesome. So, let's look at 5. Let's move this up. I'll try to cover it up so it just gets a little bit less confusing. And as I said before, if you guys want to give it a shot on your own, which I encourage you to do that, pause it. Pause it and give it a shot. Okay, a snail slides 14 centimeters north in 28 seconds. So let's highlight that. So 14 centimeters north in 28 seconds. We want to know average velocity. Awesome. Oh, here we go. So what do we have? We have distance. Distance equals 14 centimeters north. I'll put that there. We have time. 28 seconds. So we're trying to find average velocity, which is this formula right here, right? Change in distance or change in displacement divided by change in time. Okay, so formula equals average velocity equals change in distance divided by the change in time. Okay, so let's do it. Our distance, and remember, if it doesn't give us a beginning, you just assume the beginning is 0. So our distance is our final distance, 14, minus our initial distance, which was 0, because it started and it slid. So it's going to be average velocity equals 14 divided by the change in time. Well, 0 seconds to 28. The final time is 28 minus the initial time is 0. 28. We know it's a velocity because it does give us north. So our average velocity should equal, calculate it, see what you get, 0.5 centimeters a second north. So that's our average velocity. Okay, so what is its average speed? Well, let's look at it. Average speed is distance divided by time. So distance divided by time, rather than displacement divided by time. 14 divided by 28, it's going to be 0.5 centimeters per second. So, what's the difference between these two answers? Average speed. I know it's still V equals, but this is average speed and this is average velocity. Okay, so don't be confused by that. So, do you see a difference between these two answers? This velocity, this speed. Well, this says north. This does not. That's it. Easy, right? It's the same as above, but it does not include a direction. Well, let's look at C. How fast is the snail going at the end of 28 seconds? Again, if this is our average, we have no idea. You know, it could have slid slowly for a few seconds for 5 and then started sliding down a hill. And at that 28 seconds, it was going really fast. It could have slid really, really fast and then started sliding up a hill at like 26, 27, 28. In that case, maybe it's going really slow. So again, we don't know. We only know average. So just to put this in perspective, if this is the total track, each one of these points is a speed. We don't know what speed it's going at each point. We just know overall it was on average it was going 0.5 centimeters a second. That's all we know. We don't know how fast it was going here or here, but on average it was going this fast. Okay, so for C, we don't know. Okay, now let's look at number 7. Number 7 is a little tough, but this is where we really look at the formula to see, like, okay, am I using the formula right based on my knowledge of definitions that we've went over, okay? So, let's look at it. Joe, who is on the track team, runs the 400-meter dash. So 400 meter, if you don't know, is 1 lap around the track. That's our track, 1 lap. He ran it in 50 seconds. What was Joe's average velocity? Okay. So, a couple of things to consider, but let's look at this formula. Remember, this is displacement. Just keep that in mind. This is distance, this is displacement. So with that being said, if he starts here, he runs all the way around, well, his displacement is what? Well, it's 0, right? If we know average velocity is your change in displacement over time, and then we know that your displacement is 0, your time is 50 seconds, well, that 50 seconds goes into 0 how many times? 0. So that's our answer. 0 meters per second, I guess, per second or per time, because there was no displacement, therefore his average velocity was 0. And even beyond that, it would be very difficult to find his velocity because his direction is constantly changing because he's going in a circle. Okay, so that's that question. We went over most of them. Hopefully you guys are getting it by now. Sometimes it takes a walkthrough, and I get that. If you guys got any questions, let me know.